Hi, in this tutorial we're going to be spending some time looking at how we build, configure, download and debug a Windows CE.NET operating system image. In this case I'm using Platform Builder as the tool to do each of these tasks. So let's get started. I'm going to create a new platform by making use of the New Platform wizard. I select File and New Platform. This brings up the Platform wizard. The Platform wizard is totally customized depending on the configuration of the operating system that I choose. For example, if I'm choosing to build a device which is headless, does not have a display, keyboard or mouse, in that situation the wizard will be customized to show me options that are applicable to that type of device. So some of the user interface applications will not be prompted to me as options to select or configure. Okay, let me hit next. So here are the list of board support packages that I can choose. In the case of this tutorial, I'm going to choose the emulator. I could choose more than one BSP at this point. This is a great option. In this case, it means that maybe my hardware is still being manufactured, still being built, and I can configure the operating system image, choose which operating system components and applications I require, and get all of my operating system image tested in the emulation environment while the hardware is still being built. If I hit next, I now get the option to select one of the pre-built configurations for Windows CE. You can see there are a number of options shown here, including tiny kernel. In effect, this will give me a 200 KB image, which I can then layer additional components on top of. In the case of this tutorial, I'm going to choose the Internet Appliance and give my platform name a name of My Platform. And then I move on to the next step. The next step in the wizard gives me the ability to choose applications and media. I have, for example, could choose the .NET Compact Framework, which in this case I don't need, so I can just simply turn that component off. Once the wizard is complete, I can always go back to the catalog of components and add in any components that I need from the catalog. So in the example that I've shown here, by turning off the .NET Compact Framework, I can always go to the catalog once the wizard is complete and add the .NET Compact Framework back into my operating system configuration. Perhaps I do want the internet browser. Maybe I don't need Windows Media, so I can simply turn off those components and move on to the next step of the wizard. So the next step of the wizard is networking and communications. You can see that we have support here for personal area networking, which will include infrared and Bluetooth, local area networking, which will include support for wired and wireless networking, and wide area networking, which will include virtual private networking and point-to-point tunneling protocol. And I can simply turn this option off. I only need wired networking in this example. I hit next, and at this point the platform wizard is complete. And I simply hit finish to allow Platform Builder to generate the platform files that are needed for my project workspace. You'll notice that the user interface for Platform Builder has now changed. Previously, on the right-hand side of the screen we had the catalog, and on the left-hand side of the screen we had a grayed out area. This has now been enabled to show the platform workspace that we've just created. Inside of the platform workspace, I have all of the files needed to support the emulator, which includes the device drivers, as well as the various components from the operating system that we've chosen from the Internet Appliance option that we selected from the platform wizard. In order to run through this tutorial, I'm going to add two separate applications into this operating system image. We do this again by moving to the File menu. I select File and New Project or File. You notice there are a number of project types that I can create here, including a Windows CE application. This will be a Win32 C and C++ application, a console application, a dynamic link library, which could simply be a library of functions, a library of resources such as maybe language-specific dialogues, icons, and string tables. Or alternatively, this could be a device driver. In our case, we're going to choose a Windows CE application, and I'm going to give this a name of KevLab. I then click on OK. You can now see that I have three options: an empty project, a simple Windows CE application, and a typical Hello World application. In the case of an empty project, this means that the project files will be created, but there won't be any source code included in that project. This is ideal for situations where perhaps I already have source code from a previous project that I want to add into this application that I'm building now. In the case of a simple Windows CE application, only the entry point for the application will be created. So a source file will be created, This will have an entry point of win main, and then all of the additional code for that program will need to be written by me. Or the third option, a typical Hello World application, will have all of the code needed to support both user interface components, such as drawing the client area of the application, and everything else needed to support, in effect, a fully featured application. In my case, I'm going to choose an empty project and hit on Finish. The code for this application has already been written. I simply need to include the files into that. You'll notice that the view has now changed. We're now looking at the application view, in this case a file view, and if we expand the node here for KevLab files, you'll notice that each of the folders is currently empty. Let me go ahead and add in the required files for this application. So I click on Project, Insert, and Files. Now I'm going to browse to a folder on my machine and select all of the files that are needed for this application. You'll notice that the user interface for Platform Builder has now changed to show that the source files, resource files, and header files folders now contain components. And you can see that the kevlab.cpp or C++ file now exists under source files. I can also select the class view, and the class view gives me a different view onto this application. So in this situation, this shows me each of the exposed functions and each of the exposed variables included inside of this application. I'm now going to add a second application to the platform. Again, I select File and New Project or File. Again, I'm going to choose a Windows CE application, and I'm going to choose the project name of regapp. This is going to be an application that reads a customized registry key from the operating system, and when the application starts, displays that registry key to the user. I click on OK, and in this case I need to select a typical Hello World application. I want Platform Builder to write that code for me. I click on Finish, and again the user interface will update to show that I have this new application. Already you can see a difference here between regapp and KevLab. The last time I generated an application, the source, resource, and header file folders were all empty. In this case, source files already contains the application, resource, and standard AFX files. And if I switch over to the class view and expand regapp, you'll notice each of the exposed functions and member variables are exposed here. In my case, I want to open up the Windows procedure or WinProc function. This takes me directly to the WinProc function inside of my application code. You can see the switch message here as part of the WinProc that is used to evaluate which message is being delivered to the application, and then I can add in any additional code that's needed to handle those functions. What I'm going to do here is just paste in some pre-written code for this application, and you'll notice that this handles two distinct cases. The first one being WM_char, or a keyboard character being hit on the keyboard, and in the case of this keyboard handler, we're looking for a lowercase x. And if we get a lowercase x, we display a hello world message to the user. The second handler that we've added here is WM_create. Now this WM_create handler is activated before the user interface is displayed to the user. This is a great place for you to create any child windows or any additional controls that are needed for your application. In our case, we're simply going to read a custom registry key and display a message box to the user with the contents of that key. Okay, so by default, the registry key that we're reading is not included in the operating system image. What I need to do now is switch over to the parameter view and add this custom registry key to my platform. So I'm going to expose the My Platform parameters, come down to the emulator, project-specific files, and open up the project registry file. If I scroll this to the bottom, I'm then going to add in the custom registry key here. Instead of your name goes here, I'm going to put something interesting like cool tools. And at this point, I'm pretty much ready to build my operating system image. I've added the two applications that I needed, and I've also added the custom registry key to the platform. Right now, you'll notice that we're building a release image of the operating system. We want to do some debugging of the operating system. So before I build the OS, I'm going to change this from a release image to a debug image of the operating system. Again, before building, I just want to make sure that the build options are correctly configured. So I'm going to select Platform and Settings. I click onto the Build Options tab, and there are a couple of options that I want to enable here. The first one being Enable Event Tracking during boot, and also Enable Profiling. This will give me the ability to make use of some of the remote tools that ship with Windows CE.NET. Okay, I'll click on OK at this point to set those options. I'm just going to switch back to the feature view for 1 second before we build the operating system image. You'll notice now that we have 3 items under My Platform Features, one being the device drivers for the emulator, the second being each of the components that we've added from the catalog or through the platform wizard, and the third being user features, and this will be the 2 applications that we've added into our platform. One of the things that I want to show you as part of this tutorial is access to shared source within Windows CE.NET. So I'm just going to expand the Internet Appliance folder, move down into File Systems and Data Store, into the Storage Manager, into some of the File System Helper functions, and open up some of the source code that ships with Windows CE.NET. If I scroll this file down, you'll notice a function here called allocfsd. What I'd like to do is set a breakpoint on this line here, which we'll use when we download the operating system to the emulation environment once the operating system is built. At this point, we're ready to build. I simply click on Build and Build Platform to start the build process. The build process will take approximately 10 minutes to complete. So to save time, we're going to reduce the amount of time in the video. Okay, so now that the build is complete, we're ready to move on to the next step. Before downloading the operating system to the target, I just want to check the download options that have been enabled for this image. So I'm going to select Target and Configure Remote Connection. You can see that for both download and kernel transport that I'm currently configured to make use of the emulator for Windows CE.NET 4.2, which is fine because we're using the emulation environment. I'll also click the Configure button for the download transport, and you can see now that I'm using a skin file rather than the default 800 by 600 by 16 bits per pixel. And in this case, I'm using the WebPad skin file. I have my memory set to 64 meg, and I'm using outgoing Ethernet only, outgoing networking only, and I'm not using any of the hardware pass-through for serial or parallel ports. All of this is just fine. So I'm going to click on OK and click on OK. I'm now ready to download the operating system to the target, which in this case is going to be the emulation environment. So I select Target, Download, and Initialize. You should see the emulation environment get started, but because we have a breakpoint set in some of the shared source for Windows CE.NET, the breakpoint will fire before the operating system image is fully booted into the emulator. You can see that we've got this security warning dialog being displayed. This is a KITL or kernel independent transport layer security warning. This is saying that if we allow KITL to connect, this will enable a shared folder between the emulation environment, which will be called release inside the emulator, and the build release folder on our desktop machine. This is actually a really neat feature. It means that I can drop files that I'm using on my desktop into the build release folder on my desktop, and those files can instantly be seen by the emulation environment. But the reverse is also true. Any files that I drop into that folder called release inside of the emulation environment are also immediately visible to my build release folder on my desktop machine. So I'm going to click on Yes. The operating system is now being loaded, and we can see some debug output messages being displayed at the bottom of the screen. As the operating system loads, you'll notice that the screen changes and our platform workspace and the catalog have both now disappeared. If we want to still see these, I can simply click on the View menu and bring these back on. Obviously in this case, I probably want to see as much of the source code and debug output messages as I can. We set a breakpoint before downloading the operating system, and the breakpoint was set on this line right here. the breakpoint has fired. We can tell that the breakpoint has fired because we have a yellow insertion point arrow being displayed on the left-hand side of the screen. And we also have a break message being displayed on the caption bar inside the platform builder. So we're at a breakpoint, and the source code that we're looking at here is part of the file system driver code for Windows CE.NET. It would be kind of interesting to find out exactly which driver is being loaded at this point. Unfortunately, inside of the function allocfsd, we don't have access to any of the member variables or source code that contains the name of the driver that's being loaded. However, we can very easily see this by making use of the cool stack inside of Platform Builder. I click on View, Debug Windows, and Cool Stack. Right now we're in the function allocfsd. The function that called us is called fsdload. So let me just double click on this function. You'll notice the source code has changed. I'm just going to close down this window. And you can actually see here inside of the function called fsdload the call to the function that our breakpoint fired in, which is called allocfsd. We have this interesting structure here which is called pinitData. Now I already know that pinitData contains the name of a variable that holds the name of the driver that we're loading. And I can right click on this and simply do a quick watch on the contents of pinitData. If I scroll this window down, the name of the driver that we're loading is here, scFilesysName, and the name of the driver that we're loading is called relfsd. It just so happens that this is the released file system driver, or the driver that is responsible for the sharing of a folder between the emulation environment and our desktop machine. Okay, so I'm done with this. I can simply click on Close. And I want to clear the breakpoint that we've set so this doesn't fire again. I select Edit and Breakpoints. And here's the breakpoint that we've set. I hit Remove All and OK. And our breakpoint is now being cleared. At this point, the operating system is halted, so it is not booting inside of the emulation environment. We need to allow the operating system to continue loading so that we can make use of the two applications that we added into our operating system image earlier in this presentation. So I'm going to select Debug and Go. We should see a number of additional debug messages being displayed, and once the operating system has loaded, it should then become visible inside of the emulation environment. We'll then be ready to run the two applications that we added to the operating system image. The first one is an application called regApp, and the regApp application will simply display the contents of a custom registry key that we added to our operating system image. Okay, so the emulation environment is now fully loaded. I'm going to browse to My Computer. And I'm then going to open up the Windows folder inside of My Computer. And this will contain the regApp and also KevLab application. So here's the contents of the Windows folder. You'll notice that by default, the two applications, regApp and KevLab, are not visible. In order to view these two applications, I need to click on View and Options, and remove the Hide Protected Operating System Files checkbox, and then click on OK. The screen should then refresh, and once this is refreshed, we should see both the regApp and KevLab applications. Okay, so here's regApp. Let me just go ahead and run this. And you can see the message box being displayed that contains the words Cool Tools, which is indeed the registry information that we added to the platform before we built the operating system image. The second thing to note here is that the Cool Tools message box is being displayed over the top of the Windows folder. You'll remember that we added the code to read the registry key and display the message box into our wm_create handler. And this is handled by the application before the main window is displayed, which again is a great way for you to add any child controls into that main window. When I click on OK, the main window should then be displayed. And here it is, and this is simply showing hello world. If you remember from the code that we added to the RegApp application, there were two handlers that were added. The first one for wm_create, which is reading the custom registry key and displaying a message box. And the second one was a keyboard handler, and we're specifically looking for a lowercase x key to be pressed by the user. So if I press the X key on my keyboard, again a message box is displayed, and in this case it's displaying the message hello world. I simply click on OK and that will dismiss the message box. Now you might be asking yourself why this is particularly interesting. Well, if I have a look at the skin file that we're using inside of this emulation environment, this has a number of buttons on it. In effect, this could simulate a keyboard, a virtual keyboard for your device. So I have an X key here, a Y key, and also an up, down, and left, right pad. If I press the X key on the skin and then release, my application responds to that X key on the skin in exactly the same way as if that key had been hit on a physical keyboard on the device. Okay, let me cancel that message box. And then I can close down the RegApp application and also close the Windows folder. Okay, at this point we're now ready to start our second application, and that application is known as KevLab. In order to do that, I need to switch back to Platform Builder. Okay, so we're now ready to run our second application, which is a program called KevLab. Previously, we ran our first application, which is RegApp, inside of the emulation environment. There's a second way that we can run our application, and that's directly from Platform Builder. We can simply select Target and run programs, and this will enumerate all of the programs that exist in our build release folder and allow us to directly run a program from Platform Builder itself. Before running the program, I want to start a remote tool. This is a tool which is called the Remote Kernel Tracker. Let me just start the program. This will prompt me for which device I want to connect to. At the moment I only have one device enabled, which is the Windows CE.NET default device, which, if you have multiple SDKs installed, will always be the last device that you downloaded and booted to. I'm going to click OK. The Remote Kernel Tracker gives me the ability to look at various real-time events inside of the operating system, including looking at interrupt service routines and the interaction between threads inside of the operating system. The program that we're about to run, which is called KevLab, is a program that has one application global critical section and multiple threads trying to gain access to that critical section. Obviously, by definition, a critical section can only have one object at a time gaining access to it. So we should be able to see inside a kernel tracker the interaction between the threads and the critical section exposed as part of that application. So kernel tracker is now running. We can see each of the applications or processes running inside of the Windows CE operating system. You'll notice that KevLab is not currently running, and we can start this off by going into Platform Builder and selecting Target, Run Programs, and then locating the KevLab application in a list of programs in our build release folder. Now, the interesting thing about selecting Target Run Programs is that I could exclude an application from my operating system image, but still have this included in the build release folder. This gives me the ability to write programs using tools such as Embedded Visual C, and then simply copy the binary executable into my build release folder, and then select Target Run and launch the program directly from Platform Builder. Okay, so I've selected my program. I hit Run. This will start the KevLab application. We don't necessarily need to see the application running inside of the emulator, but we are interested in seeing the results of the program running inside of the remote kernel tracker. We can now see KevLab running on the left-hand side of the screen here. If I expand out the application, you'll notice that there are 4 threads running inside of KevLab. The main application thread, which is called kevlab.exe, and then 3 child threads, each of which is trying to gain access to the process global critical section. Let me just change my zoom range inside of KevLab to be 5,000. In fact, let's increase that up to 10,000. And we can now start to see the handover between each of the threads inside of the application, each one therefore gaining access to the application global critical section. This is one way in which you can look for deadlocks inside of the operating system when you're building time-critical applications. Okay, at this point we're pretty much complete. During this 30-minute presentation, we've had a look at a number of different aspects of building and deploying a Windows CE operating system image. We've configured, built, downloaded, and debugged the Windows CE operating system, and we've also made use of some of the remote tools, in particular the CE Remote Kernel Tracker.